restroom or take a sip of something or smoke them if you got them, just feel free to go out, right? The smoking lot, I don't know where you can go, but you know what I'm talking about. If you need to you get up, you don't have to ask me. Just go ahead and do it. Same on quizzes and tests. You have to use the restroom, go. When you take a quiz or a test, you can listen to music. So headphones, as long as no one else can hear it. And when hey, morning. What's your name again? Thank you. You okay with that seat? Or do you want to sit anywhere else? You're okay there? Nice. I always need a window too. So you can also use a handheld calculator on any quiz or test. You may use the school computer or textbooks only. And I give you one piece of notice. Anything you want on it. Rear anything. Front and back, one page. No excuses. Must be on your desk before you're going to take a quiz or test. You can't say to me, oh, God, I forgot to do this problem. Can I just rip that page out of my notes? No. But one page, start working on it now. Every time I teach something, add to something. All quizzes and tests, including the final unit. Yeah, so if you rip that page out, front and back. And I'll let you use the 4 edges too. The right format. I personally, whenever a teacher gave me that, I would do like 8 pages, and then save it as a PDF. You can print 4 pages per page. You can have 4 pages in the front, 4 pages in the back, and then you can start adding more sections to the pages. So start working on that. Nice. Let's do a limit. Ready? So after today, you'll be ready for this first quiz. So that means Friday, you can ask me questions, right? And then Wednesday, we're on to new stuff, but your quiz is on the material that we finished today. Does that make sense? There'll always be a day between when I teach you something and when I assess you on it. Right? Does that make sense at all? Sometimes I get in late and I'll say, well, I didn't get to make the quiz. I'll do it next class. Just be ready for quizzes every class, right? And then how are you asking me questions? You're emailing them to me. I want a photo of the question, a photo of your work, and maybe some comment. Not sure where this 3 came from, right? Kind of thing. So for Friday, send me the questions before class starts, okay? It's no big deal if I'm answering another question and you're prepping it to send it to me, that's fine, right? But I don't want you to say, hey, do problem 2.3, do the chapter 2 review, problem 2C. Then I have to go look it up, and it takes time. I don't want to do that. I want to just be able to look at your email and answer the question, okay? So it eats up class time. I don't want to do that if you don't send it to me ahead of time. Nice. Here's our first problem. Again, this one is in the chapter 2 quizzes on Blackboard. I've got the limit as x goes to -3. Of x plus 3 is downstairs. And upstairs is 2x squared plus 5x minus 3. So what's the first thing we're looking, what is the limit again? Tell me, I forget. What's the limit? More, give me more. I like it, but yes, but give me more. What do you think? The height of a function is that simple. So what you're saying, what is it approaching? It's approaching at a y value as x as I'm approaching an x, right? I'm asking what height am I moving to as I move toward the next step, right? That's simple. So how do you find the height? Well, you plug in the value, right? Plug in the value. So here I'm interested in the value at -3, but when I plug in that value, I get what? 0 over 0, right? Everyone see that? You do that in your head? 6 times what? 6 times 9? Yeah? Minus 15 plus 3, that's -0. And then negative, right? Negative 3 plus 3 is 0. So 0 over 0. And in that case, we're looking for this replacement function, right? We're trying to find a replacement function here. And I like to write this as the limit as x goes to -3 of star. So that means I know I'm working on star as this whole polynomial over polynomial piece. Right? Good. Who knows how to factor this? I personally like synthetic division here instead of factoring, or long division, but this one we can also factor, right? So what, 2 times -3 is -6, yes? And factors of 6 are 1 and 6, or 2 and 3, right? And which one is going to get me a positive 5 here? Oops, sorry. Which one gets me to positive 5? The negative 1 and the 6, and I split the middle term, right? So 2x squared plus 5x minus 3 is 2x squared minus 1x plus 6x minus 3. You remember doing this in algebra? Just say yes. Lie to me. Good, and I factor by grouping. So I get the factoring of 2x minus 1 times x plus 3. Does everybody remember doing this in the past? Good. This class is not about factoring. Factor how you wish. Okay? It's not about factoring. That's algebra. The problem is the course is heavy in algebra. I like to call it algebra 3. But I don't care how you factor. Synthetic divide, long division, factor by grouping. I don't care. Just make sure it's right. So now I have star as 2x minus 1 times an x plus 3 over an x plus 3. Is everybody with me? And don't let me go too fast. If I'm going too fast, let me know. Robert, can you slow down a little bit? Robert, how many cups of coffee did you have today? So I get my replacement function, right, as a 2x minus 1. Well, that one's pretty easy to deal with. And I certainly can plug in now. So I get my limit as x goes to -3 of star is the limit as x goes to -3 of 2x minus 1. That's 2 times a -3 minus 1. That's a -7. We would like to be able to, every question, everything I teach you, except for maybe one question, you can know if you're right or wrong by checking on Desmos. The issue is, when you're wrong, when you know you're wrong, can you keep your cool, right? Or are you going to panic? So usually if you know you're wrong, I invite you to say, hey, look at the problem again. Maybe you'll see your mistake. But most likely you're going to have to rewrite it. So you start over nice and slow, trying to be organized and see if you can get to what you know is the right answer, right? So on this one, we're going to check on Desmos. Feel free to do this with me. Again, don't let me go too fast. Tell me, if I'm your Uber driver, don't wait till you get home to write up a bad review and say I drove too fast. Just tell me to stop driving fast. So Desmos. Day. I want to plot the original function. So y equals, what did I have? 2x squared plus 5x minus 3, highlighting everything, divided by x plus 3. Put in my replacement function. What was it, 2x minus 1? Notice that if I turn the replacement function on and off, I see that they're the same function. Yes, you with me? And then I can put in my found limit, right, which was what, -3, -7? And I see it's on the curve. How are we doing? Hello? We okay? Easy? I want to remind you how to check it numerically. It's your choice when I ask you to check it. If I ask you to check it and you get it wrong, you better do it over, right? If I ask you to check it and you get it right, great. You know you have it right. So numerically, I go to the place, the original function, I click on that gear, and I click on the table, right? And I know I'm trying to get really close to -3 from the left and from the right. Right? From the left and from the right. So from the left, what numbers are close to -3? This side. Say again? -4, yeah, it's not very close, right? But I agree, -4. -4 doesn't help me that much. It's not a real good predictor. But -3.1 is. And -3.01 is even better. And -3.001 is even better. And by that time, you should be able to see it. It's -7, right? You agree? What about the other side? So getting closer to -3, but from the right-hand side. -2.9, exactly. And when you're reading the book, you'll see the book does a little weird. It's like, all right, do 0.5, and then 0.1, and then 0.05, and then 0.01. So the book asks for this a little differently than I do, but that's okay. So -2.99. -2.999. At that point, you should really be able to see, you should be able to guess, right? And you might as well put in a funny number also, right? You might as well just go crazy with it and see where it's going to go to. Nice, let's do one with a fraction. Yeah? Let's do this one. On your mark, set, go. Give you some time to write, and I'll try and shut up. What's our LCD here? Three x? Yep, so I'm multiplying by 3x over 3x, yes? Negative 1 over 18, anyone get there yet? Don't copy, just do, right? Just work on the problem yourself. You got it, right? Johnny, you already did it? How we doing? Almost? Nathaniel, yeah? You there? Good. Efren, yes? Good. Ibsa, yeah? Nice. Chadri? Good. Okay. Anybody need me to talk about it? Or any part of it confusing? Yeah. Exactly. So I factored out a 2 from the 2x minus 6. And that 2 became 2 times 3x, so 6x. I'm actually factoring out a negative 1 from here. So if you look at me distributing this, you see I get back to 3 minus x. So I finally get that replacement function of negative 1 over 6x. What's the domain of my replacement function? What's the domain of the replacement function? What x am I not allowed to use in my replacement function? X can't be 0, but I don't care about 0, I care about 3, right? Or what is it? Yeah, 3. What's my domain of my original function? All this domain stuff is in free count, right? You're going to look at that quickly and go to domain. Can't be what? 3, and then also can't be what? I think I heard someone say it. 1 over x is 0, right? So look at what the replacement function does to my original function. It takes the piece that I want to plug in and makes it in part of the domain. But the rest of the domain will stay the same. Right? The original function can't be 0 or 3. The new function is working on getting it so it can be 3. Right? So if the functions are exactly the same except at 3, the limit says, I don't care about 3. I don't care about 3. So since the function here is exactly the same as this function, except at 3, and I don't care about 3, then I can replace the function, and I can't get the limit. Does that make any sense? To anyone? Making sense to no one. All right, let's do one with the conjugate. The limit as x goes to 9 of square root of x minus 3 over x minus 9. I'd like to be able to just plug in. By the way, I'll never give you a test where you just plug in and it gives you the height because it's boring. Nothing to do. I already know you took 3 now, so you know how to plug in the number. You took the algebra, you know how to plug in the number. This one, if I plug in the 9, I get 0 over 0. Agreed? Yes? Hello? Is anyone talking today? Thank you. The limit as x goes to 9 of star. And I'm going to work on star. I could factor this one. I don't know if anyone sees how to factor this. But what I'll say is when you see a radical, you probably want to use a conjugate. So I want to use the conjugate of this. Whoops. So I need a square root of x plus 3 over itself. Yes, you with me? Anybody with me? Yes. Thank you. Thanks, Jack. So I want to distribute where the conjugate is, right? And of course, you remember we get the middle terms drop, right? I get the square root of x squared minus 3 squared all over that denominator. So I get x minus 9 upstairs. Oh, that's nice. So there's my replacement function. Remember, I'm trying to plug in 9 there, right? So the limit as x goes to 9 of star is 1 over the square root of 9 plus 3, so 1 over 6. How's everybody here? Double check this one on Desmos, please. Oh, yeah. How we do? The check okay on Desmos? It's nice. You'll know your exact score on every quiz and test before you leave, which is pretty sweet. The first question on every test is the easiest one. It says name, and then there's a blank. It's a fill in the blank question. Just make sure you don't copy off someone else on that one. All right, you ready for a tough one? No? Yes, question. Yeah, so graphically you could plot the original function, the replacement function, and the point. Numerically, you could just take the original function and do it and put in the in this case what 8.9, 8.99, 8.999, right? Which one do you want me to do? Do the what? Which one? With the numeric or graphic? Graphic. So I had an original function of square root of x, squirt, S-Q-R-T, all divided by x minus 9, right? So there's the function. Of course, I'd like to get 9 on my list. What was my replacement function? It was 1 over square root SQRT of x, right arrow, plus 3. Am I right? Remembering right? Yeah. Look at it again. Look at that replacement function is exactly the same function, right? So at least I know I got my replacement part correct. I got to make sure I got the height correct. Right, and I had to point what 9, comma 1 over what 1 over 6. There it is. Of course, the 1 over 6 is about 1.6 repeating, or it is 1.6, right? 0.16 repeating. And I can certainly just do that up here quickly with my 8.9, 8.99, 8.999, 8.9999. Yeah. So then the question that I would expect you to ask me is, well, when do I know to distribute or not? The same thing about when do I know it's a car or not? What happened to me is I say, oh, look at that cool truck, and my dad is smacking and saying, no, that's a car, it's an Eldorado, right? So the same thing, you don't teach you what a cat or a dog is or what a car or a truck is. You've seen so many of them, and you were told yes or no, you figured it out. Same thing here. You're going to do enough problems to know when should I distribute and when should I not. You're not going to get it wrong if you distribute downstairs, but it's pain. It's horrible. Right? So you're trying to say, so I know the conjugate's going to knock out middle terms, so let me use it where the conjugate, right, it's really going to make something happen. You ready for a tough one? So this is typically the one, I put only the tough stuff on the quizzes and tests. All the easy stuff is for you to practice so you can build up to it, okay? Let's do the limit as x goes to 4 of 1 over square root of x minus 1 over 2. Just times x minus 4, I guess. Yeah. On your mark it, set, go. I gave these 3 items to you in order in 1 time factor first. I want to try and clear fraction second. I want to use the conjugate third. So obviously you want to go with the clearing of the fractions first. What's my LCD equal? Yes, square root of x. So I'm going to multiply this as square root of x over x. So we're going to start working on that function separately. And I'm going to use the LCD of 2 rad x over itself to simplify to clear fractions. Yep. Yeah. Yeah. Does he yes? Okay, you stuck. So first line I see fractions, right? Within fractions. Like find my interior denominator. The 2 that's downstairs is the red x. The x minus 4 is not an interior denominator, it's the denominator of the big thing. So just take the interior one. So I need 2 rad x over itself. I'm multiplying that for each numerator, and then canceling, and then I see I need a card here. Okay? Yes. You got up to here? You okay to here? Yeah? Thanks. So you see the 2 minus red x, I need the 2 plus red x, that's my conjugate. But I have to do it over itself. It's multiplied by 1. 2 times 2 is 4. Red x and red x is x. The middle term is plus x. Don't. You can, but don't. You can, but don't. It gets messy. Right, like up here, when I multiplied by the LCD, these canceled and these canceled, and I didn't bother doing anything here. So just trying to clear track this. We okay? So Luis is not here, right? Luis Castro? Laura's not here. What? Is she not here? You see her? I can prove, Misker, if you want, I can prove that you're not here. Do you want me to? You sure you're here? Huh? Are you in Philadelphia? Are you in New York? Are you in California? If you're not in New York, Philadelphia, or California, you must be somewhere else, right? If you're someone else, it's somewhere else. You can't be here. Oh, okay. I tried. Thought I'd give you a day off of school. Laura's not here. Angel's not here. Figueroa. And Felicia. Felicia is here or no? Not here. Not here. So, lots of problems for you to practice. Let me show you again where they are. In the Chapter 2 folder, we have Chapter 2 quizzes. We also have a Chapter 2 review. The Chapter 2 review, the second problem is all algebraic. Second problem, there's 6 of them, all algebraic. Okay? Yes? Lots to practice? Reading 2-1-2-2-2-3. Yes? Good. Let's talk about something else today. When do limits fail to exist? I want to try and end a little bit early to help the students that can't get into the textbook, right? So we'll talk about this, look at a few examples, and then probably quit, okay? You've got lots to practice. I want to remind you that when you're going to, so Friday you can ask questions. Wednesday we quiz on it, right? There's always a day, a buffer, kind of. I teach you something, so we got the conjugates done today. You have a day to ask, and then I can assess. When you're going to send me questions, you're sending them to my email, right? robert.kuhar@montgomerycollege.edu. Maybe I can answer, make sure you send a picture of the problem, picture of your work, and then some kind of comment, right? If you're real careful about copying the problem down, you don't have to send me the problem from the book. You can just send me the problem on your paper. But always double check that you wrote the problem correctly, right? If you don't do that, it wastes class time. If you say, will you do 2D on the chapter 2 review, then I have to open it. I don't want to have to open it. I'm a very lazy man, okay? So I want you to send it to me so I can just do the problem right away. I don't have to waste time getting to it. Yeah, question? Every class. Every class. I just say every class because I got complaints. I always give surprise quizzes. I don't give a surprise quiz. It'll be a surprise if you don't have a quiz. Okay? All right, here we go. Limits. When do they not exist? There's 3 cases. Okay? The first one is just simply a jump discontinuity. Continuity should be obvious. Should be the roller coaster you would put your kid on, right? The kiddie coaster that doesn't have any holes in it so the car doesn't fall, right? You know what I'm saying? So that famous one that we looked at last time is absolute value of x over x, right? This has got a jump discontinuity at 0. What's nice about knowing this epsilon delta definition is that we'll be able to see on all of these why it fails to have a limit by epsilon delta. What is the epsilon? Human. Not the bullseye. The whole target. Right? And you got that white circle in the distance. Yep. And the radius of it, the diameter is white. That's one. And I said if it has a limit, it's going to work for every epsilon, right? So look at this one for an epsilon less than 1. There's an epsilon of 1, there's an epsilon, right? Here's the diameter of 2. But if I picked an epsilon less than 1, right, put it in there. We could even say epsilon is equal to 1/2, right? There's my target. What's the problem? Where are the arrows hitting? When I'm shooting the arrows, where are they hitting? What part of this picture are they hitting? Where? One more. Nope. Where? Nope. Now the function. The arrows are landing on the function, right? As I'm shooting those arrows on the function. I'm going to restrict my values so that I'm only considering the function pieces in between that delta. Obviously I picked delta as the whole thing here. It doesn't matter because it never hits the board. It never hits the board. If I pick an epsilon less than 1/2, there's no delta that's going to get these guys onto the board. We can also just calculate the left-hand limit and the right-hand limit, and they don't match up, right? What is the absolute value of x? What is that piecewise function? Who has it memorized? You got to yell for me. I can't hear. I want to pick something when x is greater than or equal to 0 and something else when x is less than 0. When x is greater than 0, it's simple. What's the absolute value of x? Do I have to change anything? No. It's just x, right? Because I'm already putting positives in. But if I put a negative in, I have to cancel it. I have to change it. I got to take a negative x. So look at my limit as x goes to 0 from the right. Absolute value of x over x is the same as what over x? Which machine do I use? The blue machine or the red machine? Blue. So I got x over x, which is the limit as x goes to 0 from the right of 1, which is just 1. So on my limit from my right, as I'm walking from my right, on that purple graph, I'm at a height of 1, right? It's pretty obvious as I'm walking from the left, I'm at a height of -1. The limit as x goes to 0 from the left of absolute value of x over x is, I'm using my red replacement function now, right? So I got a negative x over x, and that's a -1. They don't match. They have to match. Question? Say again? Yeah, it's up to me, really. I already know that I can't put x to 0 in anyway, right? For the absolute value? Where? Yeah, as x goes to 0 from the right. As x goes to 0 from the left. So this one I'm walking from the right, this one I'm walking from the left. Is that making sense? Yeah? It's a weird notation. First, I didn't show you yesterday, but what it means. They don't match up. Remember, I'm trying to predict that. What happens to 0? Can't. Jump discontinuity. Case 2. Y is unbounded. So like at 1 over x, well, let's do 1 over x squared. The limit as x goes to 0 of 1 over x squared does not exist. If I had a limit, it would be what? I mean, where's this function going? It's going to infinity, right? So I can't say it's a billion. I can't say the limit's a billion because it's going further, right? In fact, if I did say it was a billion, and I drew my epsilon at a billion, think about what's going to happen with my dartboard If I found the delta that worked, what's wrong with the picture here? What's wrong with those 2 points, those 2 lines above are getting closer and closer together, right? So they're going to stay within the delta, right? Can you agree with that? They're going to be so close to each other, it almost looks like the x-axis, right? But they're above the board. You see that they're above the board? There's always going to be something above the board. Where I shoot the arrow, there'll always be something above. So when I shrink it down, I miss the limit. I miss the bullseye. No matter how small I make the delta, the bullseye, there'll always be pieces of the function above the board. Those pieces are what tells me I don't have a limit. I got to keep everything on the board so that when I shrink the board down, it hits the bullseye. Case 3. The oscillator. Do you know any functions that oscillate? Say yes. Good. What function oscillates? Sine. Yeah? Yep, sine. So if I look at the function of sine and x goes to infinity, what's happening to my height? The function as sine goes to infinity, what's happening to the height? Can you predict what it's going to be? It's constantly bouncing up and down between -1 and 1, right? So think about what epsilon is going to work here to show me that there's no limit. If it's constantly bouncing up and down between -1 and 1, what's going to show me there's no limit? An epsilon of less than 1. An epsilon of less than 1. Because my function is going to keep coming out off the top of the function down to the bottom, out of the bottom of the function of the target. A really quite interesting one to look at is f of x equals sine of 1 over x. This one is pretty sick. So it's something like that. So let's go to Desmos. Once I get a kind of a funky table going or grid going, I like to just reopen. I could save that one and reopen another window. So I'm graphing y equals sine of 1 over x. It looks like I'm using a really fat Sharpie to paint that middle of it. Can you see that? Visualize that? So intense, it's so dense that I can't even see the spaces between the oscillations. Right? You with me? If I drew an epsilon right here, is there any of the function that's going to be off the board? Yes. That's no good for me. I need all of the arrow shots I hit to stay on the board so that when I shrink the board down, I guarantee I hit the center, the limit, the bullseye. This is a nice one to do numerically. Will you do that for me in the next couple of days? Show me numerically that this does not have a limit. So what are you going to do? You're going to do a sine of 1 over x, where x is what? What the hell's going on? Did we have more energy Monday, or am I imagining a different class? Are we okay here? Or what is it? We didn't eat breakfast today? What's a genius have for breakfast? Scrambled eggs. That's what I had. You always answer that question like that with whatever you had for breakfast. How am I going to do this limit numerically? So the limit as x goes to 0, the sine of 1 over x, right? And I'm saying it does not exist because of oscillation, but I want you to show me numerically, meaning show me the limit from the left does not equal the limit from the right, right? So what are we going to do for the limit from the left? What numbers? There's a limit on my bulb time. It'll start up again in a second, but it's okay. What numbers? From the left. Negative 0.1, negative 0.01, negative 0.001, and I'll start that up in a second. Just got to give it a little break time. What am I doing from the right? 0.1, 0.01, 0.001, right? You'll see there's no pattern at all. The left will have no pattern, the right will have no pattern. They don't match up. They start going back up, right? They're going to oscillate between negative 1 and 1, right? So you can never guess. Make sure you do that. Nice. Does everyone know what they're working on for the